All right. Good afternoon, and welcome to our webinar on understanding and managing forage diseases. Tonight's webinar is co-hosted by Agriculture and Agri-Food Canada and the Beef Cattle Research Council. I'm Stacey Domaluski, the Science and Extension Coordinator for the BCRC, and I'll be your moderator tonight. Our session tonight will last for approximately 1 hour, but may go a little longer depending on the number of questions you have during the question and answer period. If you are on Twitter, please tweet along with us tonight using #BeefWebinar. We are recording this session, and I'll email out a link to the recording to everyone that's registered within the next couple of days. So if you missed hearing anything tonight or want to watch it again, you can. And of course, for tonight's webinar, you'll be able to hear and see our presenters, but we can't hear or see you. So if you do want to communicate with us, please type into the small chat window on the control panel on the side of your screen. If you have questions or comments for our presenter tonight, you can type them in there at any time as well, and we will answer them towards the end of the hour. If your internet connection is being a bit slow, it would also help to close any other programs that are using the internet, as well as close the webcam window. This means you're not going to be able to see us, but hopefully it'll make the audio come through a little bit clearer for you. So with that, let's get started. So here's what we'll be covering tonight. And I will start by introducing our first speaker, Linda Jewell. Linda began her position as the research scientist in plant pathology at Agriculture Agri-Food Canada in 2015. Her current research involves identifying, characterizing, and monitoring plant diseases of forage, berries, and vegetables. So we should be able to hear from Linda.
Good afternoon, everyone. I hope you can hear me.
Yes, we can hear you, but we can't see you yet.
Oh, great. Sorry, let me turn on my webcam here.
No problem.
Okay, there we go. Can you see me now?
Perfect.
Okay, well then I guess with that, we'll get started. So first of all, I'd like to say thank you very much for the invitation to present to this group. I'm excited to have the opportunity to talk about plant diseases, which is something I'm excited about. And I hope that today I can give a little bit of a perspective on just some of the really nasty things that are out there that are things that you sort of want to keep an eye out for, as well as some very general management techniques that will go a long way and will make a difference for just about any plant disease that may come your way. So in terms of the things that I'm going to talk about this afternoon or evening, depending on where you're at, first, when we're talking about disease, what exactly are we talking about? What is a disease? What is not a disease? I'll talk about some management strategies that will reduce disease, as I say, under almost any circumstance, regardless of what plant you're talking about or what disease you're talking about. And then I'll kind of highlight a few key diseases that you might want to know and try and avoid in grasses, legumes, and corn. And I recognize that there's a much bigger world out there, but just for the sake of sticking to the time limit today, I tried to just highlight a few of the more interesting characters out there. So just a little bit about myself, and thank you, Stacey, for the introduction. I've done a fair bit of work in the past on pink snow mold, which is the disease that you'll see on grasses as well as on cereals. I did my PhD at the University of Guelph, which is where I really got interested in plant diseases and conducted that work. I also spent a little bit of time in Sapporo, Japan, which actually ironically has a climate not that different from where I am now in St. John's, Newfoundland. So kind of very cool, persistently humid and cool climate, which you'll hear a little bit more about, is really the perfect climate for plant diseases. And so as Stacey said, I started as a plant pathologist with AAFC in St. John's in 2015. And as the only plant pathologist really in the province, I'm lucky to have a pretty wide net of things that I work on. But one thing that I'm passionate about and that I'm expanding my research program in is diseases of forages as well as silage spoilage. So what happens after you've already collected those grasses and are doing your best to store them. I'm also doing a little bit of work to identify some denitrifying bacteria that live in wood chip bioreactors. And so if you're not familiar with the concept of bioreactors, they're an edge of field wastewater treatment strategy. So essentially a bed of wood chips that's at the edge of your field, drainage water would pass through it, and those nitrates that would be environmental contaminants are removed by bacteria that naturally inhabit those wood chips. And so we want to know who is living in the bioreactor and how can we enhance their growth so that we end up with a more effective system. And finally, I also work a little bit in blueberries and related fruits, but I won't tell you about that tonight. So first, again, just a little bit of perspective as to where I'm at. So I'm out here in St. John's, Newfoundland, and I recognize that there's a lot of people participating in the West, and so I hope to give you a little bit of perspective about some of the challenges we have out here, but also overall to have a bit of a global focus. Here in Newfoundland, this is one of the few places where we're actually actively still clearing land for agricultural use, and this is what that land often looks like. So we have a cool boreal climate, and as you can guess, the soils are quite acidic. And in addition to being quite acidic, the soils are also extremely stony. And so when I first started here, I was like, okay, I went outside with my technician. I said, let's take a soil sample and dig up some roots and take a look at some root diseases. And she said, okay, sure, go ahead, Linda. Like, take the soil auger, go ahead and take a sample. And I went like, and the first thing I did was just hit solid rock. And that's why I learned why they call Newfoundland the rock. And so our soils here are quite stony, and there are real challenges associated with using these type of fields to grow forages. But luckily for all of us, the farmers here are really very persistent and very innovative, and so things are developing, and Newfoundland has quite a thriving dairy industry as well as a growing beef industry. So as I mentioned, the first thing I think that's important to talk about is what are we talking about when we are talking about disease? And so I kind of like this sort of flowery quote, but a plant is healthy or normal when it can carry out its physiological functions to the best of its genetic potential. So when a plant is being, the best little plant that it can possibly be, and it's not being munched on by insects or, affected by any diseases, or it's not suffering from a nutritional deficiency, the plant is healthy. And if any of those problems do exist, you can say that it has a disease. And the word itself, dis-ease, kind of speaks to that a little bit. As well, it's important to break down the difference between abiotic versus biotic diseases. So biotic diseases are things that are caused by living things, and so a fungus or a bacteria or a virus is the cause of the disease, as opposed to abiotic diseases or non-biotic diseases. Those are problems that are caused by something that is not alive. So for example, a nutrient deficiency or freezing damage or ice encasement. And it's also important to point out that, of course, insects can cause very significant damage and are certainly important and also alive. We don't consider the damage they cause specifically a disease. We consider it more herbivory. And so insects, I'm not really going to talk about in my presentation this evening, although it is also important to recognize that sometimes insects can be a very important vector for disease because they can carry it from one plant to the next, and they can also carry it essentially in their mouth parts. And so insects can sometimes be an important component of disease, even though they themselves do not cause disease. So how do you know when you have a disease? And so as plant pathologists, we talk about both symptoms and signs. And so a symptom of a disease is an observation of the plant as the result of a disease. So if you look out over your field and you see that your grass is yellowing, you see that it's wilting, you see that there's weird spots that have developed, that's a symptom of the disease. A sign of a disease, on the other hand, is an observation of the actual cause of the disease. So you are literally seeing, the fungus or the bacteria that is the cause of the disease. And so one example would be to see powdery spores physically on the surface, spores that you can wipe off with your hands that are in fact the fungus growing. That would be a sign of the disease. And so knowing what you're looking for when you're looking for any particular disease will help you to narrow down what problem specifically it is that you're dealing with, and therefore what you should potentially do in order to, reduce the impact of that problem. So who cares? I hope that all of us who are participating in this webinar tonight care at least a little bit about disease. Why do we care about diseases? Well, they reduce the nutritional quality of the plant, and that's because the fungus or bacteria or whatever it is that is causing the disease is literally sucking the nutrients of the plant, which means that there are less resources available for the plant to grow and to store its carbohydrates. And so if it's trying to grow or prepare itself for winter, it's less able to do that as a result of the disease. It can cause slow growth as a result of that, or it can even lead to the death of the plant. So for example, if disease gets severe enough and causes defoliation, obviously plants need their leaves in order to conduct photosynthesis. And so if a disease gets severe enough, you can lose the entire stand. Finally, unfortunately, diseases can also be directly harmful to animal health. And so I'll highlight a few examples, but there are some plant diseases that produce chemicals that are called mycotoxins, which means essentially fungal toxins. And some of these chemical compounds can be quite dangerous to animals. In addition to diseases which happen in the field while the plant is growing, I'd also like to take a moment to talk about spoilage. And so spoilage is what happens after you've already stored it. So for example, if you're producing silage, you've got your beautiful bale, it's all well and good, it's, you know, you've tested its nutritional quality and you've decided how it is that you're making up your ration. But unfortunately, if spoilage fungi come in later, once again, they can reduce the nutritional quality so that what you've got is no longer what was tested, because again, the fungus has gotten in there and sucked away some of that quality. It can, again, be directly harmful to animal health, depending on who or what has begun growing. And unfortunately, it can also go undetected without a careful eye. So if you don't know what it is that you're looking for, it might not be as obvious as, you know, a bright green fuzzy spot, because anyone who's paying attention is not going to intentionally feed something that has gone badly spoiled. But knowing what it is that you're looking for can be quite important in ensuring that the silage or other stored material that you have is still of the quality that you think it is. So what actually causes plant diseases? So viruses, just like in humans, are sometimes the cause of plant diseases. Bacteria can cause disease. Nematodes, which are tiny worm-like organisms, they're so tiny you can't see them with your naked eye, but if you've got them all alone swimming in a petri dish, they're a little bit smaller than an eyelash in terms of most plant disease-causing nematodes. And finally, fungi. And fungi, for the most part, are what we're talking about when we're talking about plant diseases. Fungi cause the majority of plant diseases. And so that's sort of where we're going to focus the talk this evening. So as I just said, most plant diseases are in fact caused by fungi as opposed to one of those other classifications of living things. When fungi grow, they grow as hyphae, which are little teeny hair-like threads, and together those hyphae tangle themselves together to form mycelium, which are sort of big mats or tangles of hyphae. And sometimes you can see mycelium with the naked eye. And so, for example, there are some root diseases where you can literally see big black, hairs of the fungus wrapping themselves around the roots. And so once again, that would be an important sign of that particular disease. Most fungi also produce spores. Spores are, you can think of as essentially the seeds of the fungus, the way that there are seeds of a plant. So fungi make millions and millions of spores, and those spores can be spread by wind and also by rain. And water is a very important consideration for fungi, and you're going to hear me say that over and over again. So the way in which fungi survive unfavorable conditions, or things that conditions where they're not able to grow. So, for example, something that likes cool weather, how does it survive its way through a hot summer? It can hide out in dead plant tissue. So, for example, in weeds or other dead plant tissue at the edge of the field. It can also be associated with weeds or other materials that you aren't directly trying to cultivate, but that are unfortunately also hanging around in your field. And fungi can also survive by producing survival structures, for example, spores, as I just mentioned, and also something called the sclerotia. And so that's what this photo is showing, that kind of big black thing that, it honestly kind of looks a little bit like mouse poop. That's called a sclerotia, and it's kind of a big mass of fungal mycelium that's all wound up against each other very tightly, and it also has a hard, crusty rind. So if you were to take it and try and squish it in your fingers, it would be kind of difficult to smush it. And you'll also notice that typically sclerotia are dark in color, and that's because they have melanin, which is the same pigment that we have in our skin, and they have it for the same purpose. And so fungi have melanin because they want to protect themselves against the UV rays of the sun. And so these sclerotia are very resistant to high temperatures and low temperatures and high moisture and low moisture and the beating rays of the sun. And so they can be a very important type of survival structure for those fungi that do make them. There's another group of fungus-like organisms. Technically, if you're talking to a person who studies fungi, they'll tell you, that's not a real fungus, but there are many important plant diseases that are caused by them, and they're a group called the oomycetes. And they include many kind of notorious plant pathogens such as Pythium and Phytophthora and Aphanomycetes. And they are also known as water molds, and that's because the spores of those particular fungus-like organisms can literally swim through water. And so that's what this little tiny video that's on loop there is showing, is these zoospores are swimming through the medium, and they are attracted directly to roots. And so these particular fungi, they can swim in water, and so if you have moisture, being maintained in your soil, and you begin to see disease, it is almost certainly one of these type of fungi that is causing that problem. And that's because the spores can literally swim to find something to attack, and they can cause quite severe damage in quite a short amount of time. So let's take a moment to talk a little bit about some very broad management strategies that can reduce disease in almost any case. And so I think this is sometimes what we all feel like doing when we see a problem. Hopefully it doesn't usually come to quite this extreme, and there are other steps that you can take rather than just taking a flamethrower to things and trying to start fresh. So one concept that I'd like to introduce is the disease triangle. And so the disease triangle is a tool that is used by plant pathologists to talk about the different factors that play an important role in sort of what amount of disease it is that you're likely to see. And so the first side of the triangle, or factor to consider, is the host plant. So what species of plant are we talking about? Are we talking about alfalfa? Are we talking about timothy? Are we talking about a susceptible versus a resistant variety of that same plant? Because, of course, depending on which one you happen to be growing and which specific disease pressure you're likely to encounter in your specific area is a very important factor to consider when deciding what specific plant to choose. The next important factor is the pathogen itself. So again, what specific pathogens are present in the specific area in which you're trying to grow your plant? How much of that pathogen is there? Is there one spore that just happened to blow up on the wind? Or is there an epidemic going on? The virulence of the strain, so how nasty is that particular guy that has happened to get into your field and is looking to cause disease? Because there can be big variations in how virulent or essentially strong an individual pathogen can be. And finally, the environment, because it doesn't matter if you have the most susceptible host in the world and loads of pathogen, if the environment is wildly unsuitable, you're not going to get a large amount of disease. And so some of the environmental factors that I'm talking about here are things like the temperature, the humidity, the presence of available nutrients that are going to make your plant stronger or weaker depending on the conditions that are there. And these three factors together all play a very important role, as I said, in the amount of disease that you're going to see. And so as I just said, you can have the most susceptible host in the world, you can have the most virulent pathogen in the world, but if it's entirely the wrong time of year, say it's the middle of winter and you're talking about a warm temperature pathogen, the amount of disease that you're actually going to see is quite compressed, you can see. So that's not a very nice looking triangle, and that literally means that the amount of disease is going to be very small. So it's important to consider all three of these factors when you're trying to understand how severe is the risk of disease at any given moment. So an important consideration, as I've just said, is specifically what are you actually going to plant out there in your field? And the most important advice is to just consult with local extension staff or to take advantage of other local knowledge that's around you because it's not something that has a blanket answer. It's really important to select the appropriate species and cultivar for your specific region and for your specific purpose. Because if you're looking to grow grass for pasture versus if you're looking to grow alfalfa that you're ultimately going to ensile, the answer to that question is going to be very different. It's also very important to select resistant cultivars wisely based on what the actual threats are in your field. And that's because resistance comes at a cost. And so plant pathologists like to say that you don't get a free lunch, you don't get anything for free. And that's because if a plant is resistant to a disease, it's resistant because it might be making something extra. So for example, it might be making a defensive enzyme that's going to allow it to attack a pathogen when that pathogen tries to attack it. But there's a cost to making that extra enzyme. And so if the plant is sort of always on high alert, looking out for this pathogen, it's sort of stressing itself out. And if that stress is never there, you're actually going to get a lower yield than if you planted a susceptible cultivar of something that, the threat just isn't there. So it's important to select resistant cultivars based on what the specific threats that you're expecting to see actually are. If you're talking about annuals, such as corn, it's really important to rotate those through. Don't just grow corn every single year and not expect to see problems beginning to accumulate. And that's because I just mentioned fungi make spores, they make sclerotia, and these fungal structures will hang out in the soil and persist, and they'll be waiting there next year if you plant that same plant again. And so it's really important to rotate through a variety of different types of host plant whenever it's feasible to do so, so that you're giving time for that pathogen to die before you reintroduce that same susceptible plant. So whenever it's feasible, rotation can be a very important disease management strategy to consider. It's also important to consider the impact of fertilizer because sometimes people look out and they see, oh my gosh, my grass is yellow, I have a great idea, I'm going to apply manure. And that can be a problem for many reasons. So first, depending on what time of year it happens to be, you may be promoting the continued growth of the plant at a time when that plant needs to be, for example, preparing for winter and shutting itself down. And so if you're encouraging all this lush green growth at this time of year, when that plant is about to get slammed under snow for, 3 months, 4 months, 6 months, depending on where you happen to be, you're really setting that plant up to get damaged by, abiotic factors such as the cold itself, as well as fungi that actually prefer living in cool temperatures. And I'll talk a little bit more about some of those specific diseases a little bit later. So it's very important to make sure that you're not doing something that's discouraging the plant from doing whatever physiological tasks it needs to perform based on the time of year it is. It's also important to remember that you may be actually providing more food to the pathogen, because if there's a serious disease outbreak going on and you're fertilizing, you may be thinking that you're fertilizing to encourage the plant to grow and to fight back. But what may be going on, depending on the specific pathogen that's there, is you're just giving that fungus, a delicious, healthy green salad to munch on. You're not helping it to outgrow it, you're actually feeding the pathogen. And so unfortunately, fertilization in some cases can be actually encouraging the pathogen itself. And that's also because fungi themselves need nitrogen. And so depending on, again, the specific disease that is there, applying nitrogen specifically may directly benefit the pathogen in addition to providing it with more food by growing the plant itself. Finally, again, with fertilizers, it's possible to have too much of a good thing. And so by over-fertilizing, you can cause tip burn, you can cause abiotic stress. Of course, it's possible to over-manure or over-fertilize your fields. And unfortunately, that's something that I do see quite a lot here is people think that you can't have too much of a good thing, but unfortunately you can. And so it's important to apply at the recommended rate depending on the nature of your soils and the plant specifically that you're growing. Something that feeds well into that is the fact that at this time of year, or it may have already passed depending on where you're at, it's very important to consider when you're going to take your final cut. And that's because when you're talking about perennial plants, as I mentioned, they need to physiologically prepare themselves to survive during the winter. And so if you go ahead and you cut them while that plant is still actively sending its nutrients down into the crown, which is, of course, the part of the plant that's going to ideally survive during the winter, you're essentially cutting off its supply chain prematurely. And if you do that, its supplies are going to run out. And so if you cut it too early, first of all, you're going to cause that supply chain to run low, and that plant may die during the winter because essentially it may starve to death. But you may also be encouraging that plant to begin growing again at a time when it should be shutting down. And so once again, you're sort of setting the plant up to fail by encouraging its growth at a time when it needs to be slowing itself down. And so the problem too is you may think by cutting, of course, you're supplying yourself with a second cut or a third cut that's going to help you to get through the winter. But unfortunately, what you may also be doing is setting yourself up to fail in your first cut of the following year, because you're setting the plant back so much, it's going to have a really difficult time recovering and getting going at the start of spring next year. And so it's really important to make sure that you time that final cut of the year very carefully after the plant has begun to go dormant, because the reduction in nutrients that you may see as a result of cutting a little bit later is almost certainly worth it for the sake of getting a better first cut in the following year. Sometimes when you see disease, one of the best things you can do is just cut it out. So if you're planning to cut in a week from now and you look out at your beautiful alfalfa field and you see that there's a disease outbreak on the go and there's a high chance that you're going to start seeing defoliation going soon, again, the reduction in yield and nutrient value that you're going to see by cutting a little bit earlier than you would have liked to prefer is going to be worth it if you cut it before the disease becomes very severe. Because once the disease has become severe, the fungus is in there and has absorbed those nutrients, you sort of already missed the boat. So it's important to sometimes literally cut your losses and cut those grasses a little bit earlier than you would have preferred in order to mitigate the damage that the disease would cause. It's also really important to remember that moisture is not your friend. Obviously, it goes without saying that plants need moisture to grow, but it's also very important to remember that fungi, the spores, need water to germinate. And so anything that you can do to minimize leaf wetness is really helpful. And so if you are using an irrigation system, it can be as simple as turning it on and irrigating as early in the day as possible, so that any leaf moisture is going to be, burned off by the sun during the day, as opposed to wetting those leaves at the end of the day when, of course, during the evening the temperature is going to drop and that leaf moisture will persist. Because if you encourage moisture to persist on your leaves for longer than it absolutely needs to be there, you are really inviting disease to take hold. And so this picture is just some kind of overly long grass that is flopped over on itself. And even that kind of flopping over on itself, that traps humidity, that is also something that can be a major problem that, again, will sort of encourage disease to take hold. Oh, I guess that's not overly long grass after all. As I said, moisture is really not your friend for several reasons. So in addition to leaf moisture, it's also important to consider the moisture that's going to persist in the soil. Roots can drown in poorly drained fields. And as I was mentioning earlier, it's very important to consider the risks that can be caused by certain specific classes of, well, fungi-like organisms. And so again, those oomycetes, they prefer very wet fields. And so if you have very poor drainage or very heavy soil, an important thing that you can consider is installing tile drainage if you haven't already, because encouraging that moisture to have a way in which to leave the field will not only allow your roots to breathe in the way that they need to, but is also going to help to drain that water away to prevent these particular fungi from kind of getting in there and swimming from one place to the next. Because as I said, these guys, their spores can literally swim. And so you'll see if you, for example, have a bit of a low-lying area, that's when you'll often see these diseases beginning to take form. And if you have, say, a ditch that's caused by heavy equipment, you will see a streak of disease across the field. It's really remarkable what these specific guys can do. And so anything that you could do to reduce moisture on the leaves as well as persisting in the soil can make a very big difference. It's also important to remember that when it finally comes time to store that material in whatever way you're going to store it, if you ensile overly wet plant matter, once again, you're kind of inviting problems to happen a little bit later. And so, of course, when you're talking about, for example, ensiling, you're expecting a natural fermentation process to happen. However, if there is more moisture there than there should be, the organisms that are responsible for the actual fermentation won't necessarily be the major species who ends up being there. So first of all, you might not get proper fermentation, so you might not get proper preservation of the plant, but you can also get spoilage happening. So just like a piece of bread that you leave on the counter can go moldy, especially if you've kind of allowed moisture to be there, or if it's in a humid kind of area, spoilage organisms can take hold in your silage. And as I was mentioning earlier, that can be a kind of an insidious problem, especially if you're feeding from, say, a bunker-style bale. And that's because it can be really difficult to examine sort of the entire space surface, and you might not realize that there is a kind of a center of rot that has taken hold. And as I said, the problem there, too, is, you know, everyone sends things away to, of course, make sure that the nutrient value, that you know how to, of course, mix up your rations to end up with a nutritious feed. But if rot happens after you've already sent away for those tests, you might not be aware that a problem has occurred and that your animals are not receiving the nutrition that you think that they're receiving. And again, unfortunately, there's a possibility that those organisms that are causing the spoilage to occur can also be producing dangerous chemicals that can affect the health of your animals and can potentially decrease the value of your product. And so this is a photo of, unfortunately, what things can look like when they get quite bad. And so you can see there's some obvious green, there's some kind of reddish stuff growing here, and no one who is paying attention to what they're doing is going to intentionally feed something like this. But this is just an example of what, unfortunately, can and does happen. And something, and I mean, unfortunately, in this case, it happened because the grower had the best intentions, but the weather did not cooperate, and he was forced to ensile when the material was very wet, and unfortunately, this was the result. So let's switch gears a little bit and talk about some common diseases in the field. So sort of the good, bad, and the ugly. And the photo in the background here, this is my favorite fungus. This is the pink snow mold fungus. And you can probably see where it gets its name, such a beautiful pink color. I'll talk a little bit more about this later because it is something that you'll see very commonly, but ultimately is not necessarily a very serious problem, depending on when it is that you see it and how it is that you're able to deal with it. And so I said the good, bad, and the ugly, but I mean, are all plant diseases good, bad, or ugly? I mean, they all have their varying degrees of importance. And so some plant diseases might be very common, so it's likely that you're going to see them, but it's not very likely that they're going to cause you very significant yield loss or economic loss, and they don't typically pose a threat to the health of the animal. Things that I've labeled with like kind of a yellow stoplight might cause significant yield loss or plant death if they're allowed to go totally unchecked, or if you're very unlucky and have a very susceptible plant or a very virulent pathogen that happens to come in. And finally, things that are labeled with a red stoplight are the diseases that you really want to do your best to avoid, because they are very likely to cause you very serious economic loss or pose a threat to animal health. So first, let's take a moment and talk about some of those key diseases in grasses and cereals that I'd like to highlight. And so the first one is a red light one, and it's one that I showed earlier, and it's a disease called ergot, and it's caused by a variety of different fungi in the group claviceps. And so the things that are going to favor this are high humidity, which is something that you're going to hear me say over and over again. High humidity or high air moisture or persistent leaf moisture, those are all factors that are going to increase the risk of just about any plant disease that is out there. This particular disease also prefers sort of warmer summer temperatures. And when you will sort of see this disease most prevalently is at the time of seed. You will begin to see those particular sclerotia. And so that's a very distinctive feature, is those kind of big black sclerotia that, like I said, if you just saw them lying on the ground, kind of look a little bit like mouse poop. But unfortunately, there is essentially a version of this fungus that can attack almost any type of grass or cereal that is out there. And this is a fungus that can produce very dangerous mycotoxins. And so just to talk very briefly about mycotoxins, as I said, those are basically fungus toxins, so chemicals that are produced by particular fungi that could be dangerous. And the one specifically that's produced by this, I think, is interesting. This is its chemical structure, lysergic acid, and there's going to be a test later, so make sure you write this down. But the reason why this particular plant disease is important is because lysergic acid, that's its chemical structure. Here it is overlaid with LSD. And so there's a theory that not everyone agrees with, that the Salem witch trials may have been sort of tied into this particular disease caused by humans eating rye that was contaminated with this particular plant disease. And so people didn't know what was going on, but people were acting crazy. And unfortunately, this chemical can also cause severe restriction of your blood vessels, which can lead to gangrene and all kinds of other pretty nasty symptoms. It can also be very severe for pregnant humans or pregnant animals and cause spontaneous abortion. And so when this has occurred in the past, there's a theory that people may have tied this into the Salem witch trials. But again, this is quite a well understood problem, but definitely one that if you see it in your field, it's not one that you'd like to see. This is one that's really quite serious. Something that is quite common that you are very likely to see, but that may not cause you serious damage, is rust. And so rust is caused by a group of fungi in the group Puccinia. And something interesting about this disease is that the spores can travel really far and wide. They can be spread very far on the wind. And in some parts of the world, that is in fact how they get there, is the fungus can't necessarily survive over the winter, but the spores can blow into your fields every summer from the south. What you'll see here is very distinctive. You will see bright orange powdery spores actually on the surface, and so if you take it and rub it in your hand, that will rub off on your hand or rub off on your shoes. I've seen photos of tractors that are essentially orange because of this particular disease. And once again, depending on the species of grass that you have or the species of rust that you have, there's compatible matches out there for just about any grass or cereal that you might want to talk about. And if you planted the wrong plant, or if you're unlucky enough to get a severe epidemic, rust is a disease that can really cause quite significant damage, because it is something that does consume quite a lot of the plant's resources and can do quite a bit of damage if it's allowed to just go unchecked. Something else here to consider is that rust isn't a disease that affects only, say, the grass that you're trying to grow. It has this very complicated lifestyle that where essentially it spends part of its life on a totally unrelated plant. So the really classic example that plant disease scientists like to talk about is a relationship between wheat rust and a plant called barberry, which is just a little shrub. But depending on which specific plant you're talking about, the alternate host for the rust pathogen is a totally different plant. And so unfortunately, it's not enough to just keep an eye out on your grass itself. It's important to remember that unrelated plants can also be a host for this disease. So this is another case where it's important to consider what is living in the sort of the edges of your field that might kind of come back to bite you. This is a disease that I wanted to highlight because it's something that I see quite a lot of here in Newfoundland. And so here many farmers rely quite heavily on Timothy because it's something that's pretty reliable given our pretty unreliable climate. So everyone has been growing it for many years because you can be assured that you'll get a decent yield off of it versus other grasses that just might not produce for you. But unfortunately, Timothy is the only grass out there that is susceptible to this particular disease, which is called purple eye spot. And you can see why it's called that. Essentially, you end up with all these little teeny spots that have a purple edge and sort of a tan center. And this is a disease, as I said, that is really only in Timothy grass. It doesn't affect any other species of grass. But this pathogen is associated with another fungal toxin that seems to be able to produce light sensitivity in animals. And so there's some evidence to suggest that animals who consume quite a lot of this grass while it's fresh may be susceptible to sunburn and other problems, skin problems, as a result of the consumption of essentially this fungus. So one that sort of there's more evidence being gathered, but something to keep a bit of an eye out for if animals are eating this grass fresh. Another disease to highlight is something called choke. Choke is caused by a variety of fungi that, depending on who you're talking to, this fungus, under most circumstances, can actually be quite beneficial for the plant because it lives in what's called an endophytic relationship. And so it lives inside the plant and it helps to fight off other fungi or other pathogens that might be trying to attack that plant. Unfortunately, one thing that the plant, essentially doesn't want to happen is to be eaten by a herbivore. And so one of the things that this fungus also does is unfortunately produce toxic chemicals that are called alkaloids that, again, can be quite dangerous for animals when they eat them. And so an outbreak of this particular pathogen is something that can be serious if animals are consuming this grass, again, especially if they're consuming it fresh. I want to take a few moments to highlight some of the cool temperature diseases because that's where my heart lies. So something that you'll see if you're looking out in your field shortly after the snow has melted, you'll be very likely to see gray snow mold if you're somewhere where snow is likely to persist over the whole summer. So here in Newfoundland, where we tend to get a lot of snow and then it melts, and then a lot of snow and then it melts. This particular pathogen is not something that's very severe, but where I grew up in Ottawa, for example, grass is everywhere. This is quite a significant pathogen that you will see. One very distinctive feature of this pathogen, or this disease rather, is the sclerotia that you'll see all over the grass, and so that's a sign that what you have is specifically gray snow mold instead of pink snow mold, which I'll talk about in a few moments. And this is a disease that is a problem because essentially what happens is during the winter under the snow, this fungus is having a party all by itself because it really likes really cold temperatures. And so under the snow, where your grass is hopefully dormant and just sort of hanging out, the temperature is a lot warmer than it actually is, outside of the snow. So while we're all getting hit in the face with minus 20 degrees and wind and all that kind of stuff, underneath the snow, it's a little cozy, humid environment where the temperature might be, -1, -2, so really quite mild. And that's actually the temperatures that this particular fungus really prefers. So the problem here is that during the winter, this fungus is going crazy and causing all kinds of damage, and you may not know that it is there. And then once the snow is melted, it's all you can do to get things kind of growing again. And if this has been allowed to become severe, it's something that can really cause quite severe economic damage. Another disease is pink snow mold. It has many names, including fusarium and microdochium patch, and that's because the people who study fungi can't agree on what the name of this particular fungus should be. But as I said, this is my favorite fungus because it's one that I've worked on quite a bit. And you can see that the reason why it gets that name is because it actually causes the plant to have quite a pinkish or sometimes a bright orange kind of color. And so this is sort of what it looks like when you see it in the early spring. So this is what it looks like because just like the gray snow mold fungus, the pink snow mold fungus grows under the snow in that kind of humid, cool, cozy environment, and it has a party all by itself. And this is a fungus that you're going to get if you don't have very persistent snow cover. And the problem with this fungus is it has a much wider temperature tolerance than the gray snow mold fungus. The gray snow mold fungus, you're really only going to see if you have very persistent, very heavy snow cover. The pink snow mold fungus is something that here in Newfoundland, we pretty much see year-round. So anytime you have sort of cool, rainy weather, like 10 degrees, 15 degrees, you can see this fungus start to take hold. And the problem is that if you see a lot of it in the fall, it's just waiting to cause severe damage during the winter under the snow. And so it's something that when you see it, it's important to do whatever you can to minimize the amount of lush green growth that you're allowing that plant to go into the winter with, to minimize the amount of damage this fungus is able to do while you're unable to act on it. I'd like to take a few moments to highlight a few diseases of legumes. And so I talked a little bit about this already, but this is Phytophthora rot. And so Phytophthora is one of those water molds that I was just mentioning. And so the water molds typically are root pathogens. And so they tend to be a severe problem when you have soil that is very heavy and that is very poorly drained. And this is the result that you'll see. But it's sort of a bit of a catch-22, because this is a pathogen that prefers very moist weather and kind of cool weather for it to actually get into the plant and begin to cause disease. But you typically won't begin to see symptoms until that plant is stressed by drought or by high temperature. And so when those problems begin to happen, because the root system has been damaged by the pathogen, that's when you're going to see that the plant isn't able to access the little bit of moisture that is there. And so that's the real problem with Phytophthora, is it might be causing severe damage and you don't realize it until all of a sudden, you're like, finally the rain has stopped, and all of a sudden your plants become very stressed because the roots have been damaged by this particular pathogen. Aphanomyces is also a similar fungus that can cause similar problems, but something that's a bit of an emerging issue. And so once again, the problem that you'll see is your plants are stunted, they're wilting, they're dying when there's sort of droughty type of conditions. However, it's important to remember that the pathogen itself is really encouraged by very wet soils and not necessarily the warm temperatures under which you'll begin to see the symptoms. Black patch is a disease of clover, and the fungus is currently called Rhizoctonia, although again, the people who study fungi very closely are in a little bit of disagreement about what specific group this particular fungus belongs to. But anyhow, the reason why I wanted to highlight this particular disease is because it can cause alkaloids that, again, are dangerous to animals that are eating this plant fresh. And so it causes a disease or symptoms in animals that are called the slobbers, because essentially those animals, I mean, the name says it all, begin to slobber uncontrollably, and they can actually become dehydrated. And so this is a clover disease that's certainly one to keep a bit of an eye out for. It's not necessarily going to cause severe damage to the plant, but something that you definitely don't want your animals in pasture to be eating very much of. Verticillium wilt is a disease that has caused historically quite a bit of disease in many legumes, and so it's caused, of course, by a fungus called verticillium. And this is also a disease where the damage is done sort of within the stem or within the roots of the plant, and again, where the symptoms are going to appear very severe when the plant has become stressed and isn't able to access water. And again, that's because the tubes within the plant that will be transporting that liquid have become clogged up by the fungus. And so a symptom that you would actually see is the discoloration of the material inside the plant itself as a symptom of this particular disease. And if you're not planting a plant that's resistant to verticillium and you get this disease, it can really cause quite severe economic damage. There are about 1 million diseases in legumes that are all some variation of leaf spot. And so I won't spend very much time on these. I understand we're getting a little bit short on time. I just wanted to highlight that there are a number and that they can look a little bit similar to one another, but unless they become truly epidemic, this might be the kind of thing that would spur you to cut a little bit earlier than you might otherwise for the sake of avoiding defoliation, but otherwise is not going to cause very significant economic damage to your plant. And so there's lepto leaf spot, which is also called pepper spot. There's common leaf spot. There's a rust that I don't have photos of. There's spring black stem and leaf spot. There's summer black stem and leaf spot. And again, the key thing here is to identify when you're beginning to see quite severe amount of this. This is the kind of thing that would spur you to cut a little bit earlier. I also want to take a moment to highlight winter kill, and so this is something that is primarily an abiotic cause. And so alfalfa specifically, and again, something that we see unfortunately here quite a lot of in Newfoundland, is severe winter kill of our legumes. And this happens because we don't have persistent snow cover. And so what happens is the snow melts, the plant is exposed to very cold temperatures that the snow would normally protect it from, and the plant also suffers from ice encasement because, you know, that snow melts, and then when the temperature drops again, it all is turned to ice. And so You might be wondering whether it's a disease that causes this, or whether it's the plant suffocating, or whether it's the plant being exposed to cold. And unfortunately, the answer is all three are usually playing some role in this problem. And it is unfortunately something that can be quite severe, and it is also unfortunately something that there's not a lot you can do about outside of planting a variety that is more resistant to these particular types of stresses. Finally, I'll just take a few moments to talk about corn, and then I'll wrap things up. And so there are a few diseases of corn. So just to give as an example of an annual plant that you should be aware of. And so gray leaf spot is one particular disease that can cause quite severe damage if you are not planting a resistant variety. And what you'll see with gray leaf spot is these very small, sort of rectangular spots developing on the leaf of the plant. Northern leaf blight is, again, unfortunately something that seems to be becoming more and more of a problem. And so what you will see for northern leaf blight is actually these very long streaks of disease on the leaf itself, so a very long tan lesion that is caused by the fungus Xerohylium tursicum. And eye spot is also a very common problem. And this is something that's caused, again, by very cool, humid weather. And so unfortunately, here in Newfoundland, something that's quite common and that we see quite a bit of. Finally, just to highlight some of the future directions of my own research. And so as I mentioned, I'm a relatively new scientist with AAFC, and I've worked quite a bit on grass diseases in the past, but it's something that I'm just expanding my research program here on. So something that I've been working a little bit on is taking a look at the incidence of silage spoilage. So how big of a problem is this actually? And when those silages are spoiling, who is living in there, and are they causing a risk to animals that are eating that material? So what is the risk of mycotoxins being produced? Can we identify those, and can we identify those fungi that are there? I'm also looking to characterize which plant diseases it is that we're seeing here in our fields, and what is the direct impact on the yield and the quality of the grass as a result. Because it might be surprising to learn, but it's difficult to get data on specifically what the impact of any particular disease is on the nutritional quality that you get out of the plant in the end. And so I'm working with a team of scientists in order to identify what the specific outcomes are given different disease pressures. Finally, I'm working with another new scientist at our center who is a plant physiologist who's quite keen to understand how it is that plants become stressed by low temperatures. And so we have something going on over this winter where she's gone out and buried temperature probes in our alfalfa field in order to understand specifically what temperatures are those plants being exposed to, so that hopefully we can tease out a little bit better what specifically are the factors that those plants are encountering that is causing them to become very stressed during the winter and unfortunately to have overall poor persistence. And so with that, I'd like to take the opportunity to thank again the organizers for giving me the opportunity to speak to all of you, and thank you all for your attention this evening.
Great, thank you, Linda. That was fantastic. So now we are going to open it up to questions from the audience here. So if you do have questions for Linda, as I mentioned, you can type them into that chat box on the side of your screen. If you have noticed that your control panel is closed, you should see an orange arrow near the top. If you click that arrow, it'll let you expand again, and you'll be able to use the chat box to type your questions into, and then I'll read them and we'll hear from Linda. So we did have a couple questions come in during your presentation, Linda. So the first one here is, how do we know when it's too late to cut your forages?
So assuming that you mean seasonally too late as opposed to the disease has wiped it out. It's a bit of a hard question to answer because it depends what it is, like essentially what does your winter look like. And so one rule of thumb that I've heard is that in a perfect world you want to wait until the first frost has happened because of course that frost itself is going to cause tissue damage to the plant that is going to cause it to lose some of its nutrients. But again, that small loss of nutrients to the plant that you are ultimately harvesting, that loss of nutrients is worth it in order for you to obtain a plant next year that's going to be of a higher quality than if you cut too early and, I could say, sort of rob it of its nutrients. So too late would be, in January after it's been sitting under the snow for a month. But essentially, as I would say in general, as soon as possible after the first hard frost is probably what you're looking for. And then it's just a bit of a balancing act in terms of whether or not the weather is going to cooperate, whether or not the field is too wet for you to get out there and to harvest when you'd actually like to. But ideally, as soon as possible after the first hard frost is probably what you'd like to aim for.
All right. Next question here. Would you expect to see some of these diseases in pasture grasses, or how prevalent are they in pastures?
So yes. So I tried to choose diseases that it doesn't matter whether your intention is to grow for silage or your intention is to put animals to pasture. The specific grass diseases that I talked about are indeed things that you would see in pasture grasses. It might depend a little bit on the specific grass that you are in fact growing and the cultivar of that grass that you're growing, but those diseases are indeed things that you would see. And one thing, I'm sorry, that I should have mentioned is that in some ways, storing grasses as silages has the advantage of actually killing many of these diseases. So a fungus that is causing a disease in the field, the fermentation process will almost always kill it, as well as sort of inactivating any chemicals that those fungi may have produced. However, if you have plants growing for pasture and the animals are directly in the field eating them, those animals are potentially at a risk of consuming some of those chemicals that can be produced. And so, again, to give the example of an animal, suffering from the symptoms of slobbers as a result of eating clover with black patch. Yeah.
Great. So the next question here, is corn a carrier of fusarium and that it will host the disease but not be affected by it, which then presents itself into a preceding cereal crop?
Yes, corn can indeed be susceptible to fusarium. Fusarium is a nasty fungus that can affect, there is, again, a variety of fusarium that can affect almost anything. And fusarium is also kind of a nasty fungus in that just one species of fusarium can attack a very wide variety of plants. And so unfortunately it is true that corn can be a reservoir for that disease and can come back and attack, as you say, a cereal disease, a cereal that's planted subsequently.
All right, perfect. So just a reminder to everybody watching the webinar, so we just have a couple questions left here. So if you do want to get your questions in, please type them into that chat box on the side of your screen, and then we'll continue. The next one is, once we're starting to already see pink snow mold, what can we do about it? Is there anything?
So it depends a little bit on what your purpose is. Are you trying to get another cut off of it before you're ensiling it, or is that a pasture grass? So in general, whenever it's feasible to do so, aeration is something that's going to help. And so if you're able to do something to help to aerate your field, especially even if you need to wait until the spring in order to do that, that's something that's going to help the grass to bounce back a little bit. However, if you're seeing it in the field and you are still intending to cut, I would recommend then to cut as soon as it is feasible to do so, without cutting too soon. And so that's a really difficult thing, is it's all a bit of a balancing act. It depends a lot on what your own environmental conditions are and what is the risk of, getting 50 centimeters of snow tomorrow that aren't going to melt and you've just lost your cut entirely, versus being able to play a bit of a waiting game or a gambling game with the fungus. So.
All right. Next question here. Are there a lot of different kinds of nematodes that affect forages?
There are a few. There are a few nematodes that can attack grasses. There aren't many, but they cause on the roots of the plant. It almost looks like kind of popcorn kernels. And very often, in general, that's a symptom of a nematode disease. And so I'm sure you're familiar with legumes. They have beneficial nodules on their roots, and there are bacteria living in those that help those plants to gather nitrogen. It can look very similar to that, and so sometimes people think that they maybe have a nematode problem, when actually what they have is those beneficial nodules where those helpful bacteria are living. But that can sometimes be a symptom. And so those nematodes, there are some that can affect legumes, and there are a few that can affect grasses and cereals.
Okay. Just a follow-up question to that one. You covered it partially already, but what are some of those symptoms? obviously you talked about the popcorn one already, but.
So because nematodes, again, are something that are affecting the roots, often what you'll begin to see are symptoms above ground, so unless you're pulling up plants and literally looking and seeing, say, popcorn or whatever on the roots of the plant. What you're likely to see is some discoloration, so the plant becoming yellowed or kind of orangey in color, and it might begin to show symptoms. So if it's exposed to sort of droughty conditions, again, because the roots have become damaged, that's the symptom that you're going to see, even though the actual cause is the nematode. So above ground discoloration and wilting can be a symptom of a root problem in general. And once you pull up that plant to take a look, if you're seeing unusual like structures on the outside of the root, that could be a symptom of a nematode.
All right. If you're rotationally grazing and you want to leave some of the grass behind to build up organic matter to hedge against drought, is there a certain percentage to balance that and protect as well as protect against diseases?
I'm sorry, that's a hard question to answer. I'm sorry, I don't think I know the answer. I think it's the kind of question, again, that would depend a little bit on what is the nature of your soil and how much organic matter do you need into it to build into it in order to get the yield that you're looking for. And so I'm sorry, I don't think I'm able to give a specific answer. Yeah.
Thanks. So next question here, does a fertility program help with disease prevention?
In a general sense, yes. So a healthy plant broadly is able to defend itself against diseases better than, an unhealthy plant that, is missing the nutrients that it needs in order to grow and complete its life cycle. And so that's something, too, that I didn't really get into, but plants do, in fact, have a natural immune system the way that humans and animals do. And so they do have tools to fight back against pathogens. So in a general sense, yes, fertilization is always a good tool to make sure that your plant is growing the way that it should be growing. However, once you begin to see symptoms of disease, fertilization will not necessarily get you out of that problem. Because the problem there, as I said, is if you are encouraging the plant to grow when it's already stressed out, you might not be, kind of allowing it to devote resources to the things that it needs to in order to most successfully fight off the pathogen.
Right. So just to let everybody know, I have 2 more questions here, and then we will shut it down. So if you do happen to have a burning question, get it in. If not, we will end after that. So can you give advice to avoid mold in silage and increase quality?
So in a perfect world, everyone is going to cut their grass at the perfect stage. Everyone is going to harvest it when it's perfectly dry, and everyone's going to make sure that when it is ensiled, that's done perfectly. So done with an additive and done in an entirely anaerobic way, so perfectly well sealed and compacted by plastic or in a bunker or however it is that you're ensiling it. But of course, reality is never as perfect as we want it to be. But doing your best in order to make sure that those factors are met, those are the best tools that you have to prevent against spoilage. Because in well-fermented silage, what happens is, it begins to heat up, and also the bacteria that cause the fermentation process to happen also really jack up the pH, and that will kill most fungi that just happen to be there. And so, as I said, if you have a piece of bread that goes moldy on your counter, that's because you're unlucky enough that a fungal spore that was floating around in the air just happened to land on it and cause, that green fuzzy stuff to begin to grow. And in general, that's the same process that happens for silage to go bad, is you're just unlucky enough that something that has come in after the fact has caused it to spoil. However, if the fermentation is incomplete, because as I said, for example, if you don't have a perfectly anaerobic environment, or if there's too much moisture and the conditions aren't right for the bacteria that naturally should cause the fermentation to occur, if the conditions aren't right for those guys to grow and you have incomplete fermentation, you might not get a complete kill of those kind of spoilage organisms that might be hanging out on the leaves, and that's when spoilage is most likely to happen. So anything that you can do to prevent damage to your bales or regularly inspect them and cover them up if you do see any will also go a long way to preventing spoilage from occurring.
All right. And this last question actually kind of follows with that. What percentage moisture should my silage be at to be ensiled?
Again, I'm sorry, that's something that's a little bit difficult for me to answer, and that's something I think that, again, depending on your region and depending on what conditions it is that you're likely to see. I would say that that's probably a better question for extension staff than for me. I don't want to give anybody advice that wouldn't be effective for their use.
For sure. All right, well, thank you to everybody who typed in questions, and thank you for Linda for answering all of those for us. So I just have a couple more things to let you know about before we can let you go. One is how to get more information and science-based production advice through the BCRC, so our resources are there as well. And well as there's some information for the Ag Canada newsletter as well. You can also connect with both of us on social media. I would also like to remind you of our next webinar, which will be coming up here in January, and we'll be talking about preventing reproductive wrecks, so make sure you join us for that one. So very shortly, as soon as this webinar ends, you're going to be asked to complete a short survey that asks about tonight's session and what you found most interested in, what you're most interested in for future webinar topics. We do need your feedback so we can do the best we can to deliver information that's both useful and meaningful to you and helps you make informed decisions on what's best for your operation. So please complete that survey for us, and don't hesitate to contact me with any questions, comments, or suggestions you have at any time. As soon as this webinar is over, you're going to be receiving an email from me in you'll be receiving an email from me in a couple of days with a link to watch the recording, as well as links to some additional information on this topic as well. And so that's it. I want to thank everybody at home for joining us tonight, and on behalf of everyone, thank you, Linda, for volunteering your time and expertise tonight. So good night.
Great. Thank you, everyone. Good night.